Hello and welcome back. Week 10. Week 9 was break, and now here we are at week 10, taking on chapter 8. Hopefully, now that we're covering wakefulness and sleep, hopefully you got caught up. Can't really do that, but hopefully you got some good rest over the last week. A little bit of a reprieve from the to-do list that you have going on. But here we are talking about wakefulness and sleep, how we stay alert and whatnot. And I start off in the course book talking about the biological rhythms that we have built into the human species. And we see a couple of them here. We have the circannual process here. This is the yearly, the annual rhythms that we have. We see the both equinoxes. We have an equinox that's coming right up, which will be the time at which the sun crosses the equatorial line of the Earth, and day and night are exactly the same length. We have another one of those on the 23rd of December, right around then. And then we have the longest and shortest days of the year around June 21st for the summer solstice, December 21st for the winter solstice, which is the shortest day of the year. Now, these changes in terms of the amount of day, of course, there's differences in terms of latitude, in terms of where you are, whether you're in the northern latitudes or more toward the equator, in the southern latitudes more toward the equator, and the amount of sunshine that we get as a regular part of the day, and its effect on our overall rhythms that happen over the year, but then, of course, on our daily rhythms. Probably the one you're most familiar with is circadian rhythms. And we see it in this chart here that I have in the course book. We have an individual whose basic biological processes happen right around these times. Now, there's some variability to this. You look at this chart and you see, the best coordination is at 2:30. Now that doesn't mean there's a switch at 2:30. There's some variability. At the same time, there's not infinite variability. The human being is diurnal, meaning we are awake during the day, asleep at night, and that is never overcome. People adapt behaviorally to that, but ultimately they end up with a sleep debt. If we avoid sleep, or we're staying up too late, or we're getting up too early in the morning over a long period of time, there's ultimately going to be biological consequences to that. So these rhythms throughout the day, they're set by the 24-hour clock, which is also reflected in terms of the length of day when we look at the circannual rhythm. So as a human being on Earth, we are connected to the time frame in which the day and year occurs on our planet. We, as a species, we're looking, at least in science fiction, if not an upcoming reality, of living on other places, such as Mars or something like that. And that would wreak havoc on our circadian rhythms if our circadian rhythms have been hardwired into our brain here on Earth and we move to Mars. It's an unknown as to whether individuals who might be born on another planet, such as Mars, would have a different circadian rhythm. Their exposure right from birth would be different in terms of their sleep-wake cycles. Would true Martians be different in terms of their circannual and circadian rhythms? We don't know. We don't know what that is. Now, the basic process that we're looking at when we think about the day-night schedule of the circadian rhythms is processed through a complex neurological connection that involves our retina, the suprachiasmatic nucleus, and the release of chemicals into our brain for wakefulness and sleep, including the release of melatonin from the pineal gland. And I have a graphic on there. Now, it's one of the questions in the quiz is to explain this graphic with as much detail as you possibly can. So we have light coming in that affects particular neurons in the retina. Those particular neurons are not for the processing of vision. They go directly to the suprachiasmatic nucleus, which then indirectly, through the PVN and the superior cervical ganglia, communicates with the pineal gland on the release of melatonin, which presence of melatonin puts us to sleep. It actually uh, encourages the development of a chemical called GABA, and GABA in our brain is what makes us feel sleepy. So if we're doing something like driving a car, I was driving a car from Portland last night and getting pretty sleepy, and that was the presence of GABA in my brain being produced here, and the melatonin was plentiful in my blood supply, and the acetylcholine was simply not doing a good job keeping me awake. So I had to roll down the window. I had to have some caffeine. I had to stop and take a walk out into the parking lot for a while, to make sure that I stayed awake, and to stimulate the notion of acetylcholine coming into my brain to keep me awake. But there's only so long I could have done that until I'm my brain is shutting me up, and you may shutting me down, not shutting me up. Shutting me down, and you've probably had those like micro sleep moments. Those are really dangerous when you're driving, but certainly when you're falling asleep and you just like lose where you're at, that is the brain pushing forward with, you need to go to sleep and you need to obey, kind of thing. So we have that. Now, I introduced here also this thing that we do for about a third of our life that we call sleep. And sleep has always been a fascination within the world of psychology and biopsychology, understanding really the question as to why do we sleep? What a huge amount of productivity we'd have if we didn't have to sleep, but yet we do. So we ask ourselves, why? Why do we have to sleep? The resting body, it's certainly adaptive that we don't consume as much energy. If we imagine how much we would have to eat just to keep us going at full tilt 24 hours a day. So there's that. There's an adaptive quality to that in terms of saving energy when there's scarce resources. There's also biochemical systems that happen in the brain in terms of toxins and whatnot being removed from our brain. There's also functions for memory consolidation, storing, making the connections between different memories and whatnot. Ultimately, producing for some of us a vivid experience of dreaming. Dreaming itself, of course, has had all kinds of different theories and whatnot throughout history that have come along with that. The current psychological theory is called the reaction synthesis theory, which means that essentially the brain is very active at night doing all of these things, and it's so this electrical firing is happening, but with the limited input of information from our sensory system, we tend to fill in the blank. So essentially, the same way we see constellations in the sky by connecting the dots, our brain very actively creates storylines or images or whatnot that we experience as dreams. Now, psychoanalytical and psychotherapeutic theories have often, courted the idea of, regardless of the source of these images, and there's certainly theories about more spiritual or collective unconscious sort of reasons why these images are in our brain, but there's certainly a logic. If my brain is going to put together a storyline, why did it put that storyline together? And maybe some aspects of our personality, some aspects of maybe things that we're challenged with or having difficulty with, come out as imagery within those dreams. Might be random, but the story's not. So since we've created that story, could it be a window into understanding some of the mental processes that we're going through at that time? So dream interpretation, looking at, well, your brain's producing all of these random firings. Why did you just dream about climbing a volcano that was active with a teddy bear? Whatever it is that you dreamt about. So for the discussion, what I'm going to have you do is share imagery from your dream, R-rated at most. Keep those dreams off the discussion board. The but the imagery within your dreams, and just taking a shot at what do you think that relates to? Why would your brain come up with that particular storyline or that particular repeated dream? What does that relate to in terms of what's going on in your life? You could even go so far as looking online, find a dream symbolism dictionary. They're all over the place. And if you've dreamt about a volcano, what's that supposed to represent in terms of that theory? And see if that helps you come up with maybe some way of interpreting your dream. So sharing that information in the discussion board. We have the role of the suprachiasmatic nucleus in regulating sleep-wake patterns. But then in the chapter, I go into how do we stay alert? And we see this balancing act that is happening as a function of the suprachiasmatic nucleus and our circadian rhythms, but the amount of acetylcholine, which is the major chemical within our brain that provides us with an alert status, wakes us up, puts us on task, versus GABA, which is the chemical that's trying to put us asleep. And we see different mechanisms here within the brain, certain brain parts of the brain that have different functions in this. I'm looking it up in the book right now. Okay. We have basically what I learned as the pons. We have the pontomesencephalon down at the right down here in this area, communicating. This is part of the reticular formation responsible for conscious attention. Axons instead into the forebrain, releasing acetylcholine and glutamate, which excites cells in the hypothalamus. That regulates our body temperature and our hunger and all that. And we also have the locus coeruleus over here. This part of look at the back of the brain stem right there. See the labels up here, but it's right there. Strong impulses in the pons is responsible for meaningful events, particularly those that produce emotional responses. This part of the brain helps to solidify memories that have high emotional content. So the actual arousal system is involved in there. We have also the hypothalamus, which is right up here. You see the labels right there, but the hypothalamus right in that area. See where all this stuff is happening here in terms of the release of chemicals all in this part of the body here. These release histamines that are active during arousal. Now, histamines help produce acetylcholine, and this is why if you take an antihistamine for a congestion, this is why you don't want to be operating any machinery. It is allowing GABA to overtake your brain, and you're likely to fall asleep. And that's where we see in the course book, we see GABA's gamma aminobutyric acid. So it is an inhibiting drug within our brains that is putting us to sleep. Now, the last part of this week is the assignment. And the assignment is actually to take that circadian rhythm image. So the person in it with the things around it. And what I want you to do is you create a single slide in your slideshow software, PowerPoint or whatever. Put that image in there. You download the image from the course book. Put that image in there. And then I want you to put labels to when the things happen for you. And see how they align with that standard representation of the circadian rhythms and when things happen, and how your own personal habits and your own unique rhythms align with those. And certainly you're allowed to explore, if your particular work, let's say, is having you work until 1, 2 o'clock in the morning, and you don't get to bed till 3, 4 o'clock in the morning, you can certainly comment on how different that is than the natural sort of experience of the sleep wake cycle and the problems that come from that. So you can add that to this particular graphic. It's a one slide presentation. Just put your name somewhere on it. That's all you have to do in terms of a title page. And then you have the graphic and you have the labels around the graphic pointing to the periods of time in which things happen for you, reflecting on how different they are or how they align with the particular things that you see in that graphic. And that's it for this week. So notice now we only have maybe 6 weeks left in the class, and there's still quite a lot of healthy brains. In fact, there's only been one healthy brain activity that's actually gone out. This needs to ramp up. We need to start sending those out. Don't want to necessarily overwhelm the campus with all of these on the same day. So I'm asking you to kind of finish up on those things, get them ready. We have a role model that is already submitted. You look, it's pretty straightforward. It's not a very complex thing. I've also created within the course a link into Give Pulse, which is the software we use for documenting community service. This is a service learning component of this class. You can go in there and you can log your hours for what you have done in your Healthy Brains project. But please, let's get those done. Let's get them out there into the community so people can benefit from your learning. That's essentially the point. And let's see if we can get some of those out pretty soon. I'd like to push a couple of them out every. Well, we have to push out several every week to get to the end of the week, end of the semester. So look forward to hearing from you about that using that discussion board. Let's get that stuff done. Don't put it off. And I will see you online. I look forward to hearing from you about those projects. Please do that. And I'll see you also in the discussion boards. Take care.